Hi, welcome to the presentation of CURAT, our master's project at the University of Bremen. I'm Daniel, and here's what we've accomplished as of July 2020. First, we'll start by explaining the background of our project and the concept known as sonification. Then, we'll go over the 5 games that the sonification game is comprised of. Between those explanations, we'll also explain some other concepts, such as our adaptive difficulty system, and at the end, the outlook and what's next for the project. Let's get started. The goal of CURAT is to develop software which can assist in the training of surgeons, specifically for minimally invasive operations. During such an operation, surgeons are not able to see the location of their surgical instrument with their own eyes. Instead, they must use spatial cognition to imagine where their instrument is located. That usually requires help from cameras, which are inserted into the patient by other assistants, and they might have access to tools which track their instrument on a computer screen. The surgeon must always be aware of where the surgical instrument is located, or they risk injuring their patient. So, how can we assist surgeons with the difficult task of spatial cognition? This is where we can utilize what's called sonification. Sonification is a way to convey information in the form of non-speech audio. In our case, this information represents the relation between 2 points in 3D space. Depending on the object's x, y, and z coordinate, the sound produced by sonification will change. For example, this is the sound that sonification produces if we need to move to the left. As you can hear, it produces what's known as a shepherd tone, a sound that seemingly keeps lowering its pitch. Here's what it sounds like when our user needs to move to the right. With what you've just heard, we're able to tell a user to move to the left or the right, but not up or down and back and forth. We need unique sounds for the x, y, and z axis, which do not interfere with each other. The sonification model used in our project was developed by Tim Ziemer, and it uses the following features based on psychoacoustical findings. Here's what each axis sounds like. Don't worry, you don't need to understand all of them. That's what our software is for. Now that we have 3 different axes, we can combine them to give our user more precise information about where they need to go. You'll hear more examples of our sonification later in the video. Using sonification to communicate spatial information has many potential applications. Surgeons could use it to hear the location of their instrument inside the patient. Or it could be used to receive more accurate audio feedback from medical devices. Pilots could use it to receive information about the plane's altitude. Drone pilots could use it to track their drone's movement. Firefighters could utilize it for rescue missions when navigating smoke-filled areas. And autonomous vehicles could use sonification to inform humans about the direction of where they're planning to drive. Now that you know what sonification is and how it can be used, let's think about how we can teach sonification to people. As you might have noticed, explaining sonification in a video format sort of works, but it's not very fun. And it's a difficult way to learn without being able to experiment or to try out sonification yourself. That's the purpose of our software, to make learning sonification both efficient and fun. The final version of our software contains 5 different games. Each game trains different aspects of sonification, and some games are more difficult than others. The sonification game can be played in one of 2 ways. The campaign mode, which presents all game in a sequence, sorted by difficulty and required skill. Perfect for learning the game and progressing through each game mode. Experienced users might wish to try out the arcade mode. Here, users can freely choose a game to play and customize which sonification axis they'd like to train. Before we move on to the individual games, let's explain how we designed our 5 games to teach sonification incrementally. Players start off by playing only on one axis at a time and learning what each axis sounds like. We allow the player to move around to try and feel how the sonification changes depending on their own position. As they continue, they move on to games which utilize 2 axes at the same time. In some games, we offer the player visual clues until they fully comprehend how sonification works. In our final games, we take off the training wheels. Players need to have a good understanding of sonification with no extra help, or they need to use all 3 axes at the same time, a true test of their skill. Now, let's finally take a closer look at each of our games. When a user first starts the sonification game, we need to introduce them to sonification. In Pinata Party, the goal is to hit a pinata while blindfolded. The only way to accomplish this is by listening to sonification. The game plays differently depending on the chosen axis. For example, if the user is playing on the x-axis, they can move left and right, and the sonification sound changes accordingly. Over time, the user should understand how they need to move in order to reliably hit the pinata. For example, if they hear a rising tone, they should move to the right. And if the sonification's pitch is going down, they need to go to the left. If it's unchanging, the user has found the pinata. All of our 5 games have a similar objective. The user needs to find some sort of target, and sonification helps them with that. After the pinata game, our users will play a very simple shell game, which would be Hütchenspiel in German. It's called Noisy Nuts. As the name implies, the user needs to find one particular shell among many. However, unlike the pinata game, the user cannot move. So the user can't try different positions to see how the sound changes. They need to correctly identify where the shell is located, which makes the game more difficult. However, the game is easier in one regard. They can track the shell's movement with their eyes. So, if there's only few shells, they might be able to correctly guess the position with a combination of sonification and simply looking at the shells. Another advantage of the shell game is that it can be played in multiple axes at once, so it can be played on the X and Y axis, on Y and Z, or, as you can see right now, it can dynamically switch between different axes. Conveniently, each axis combination has its own table in this wonderful little backyard. Now, as you just saw, each game is divided into multiple rounds, or levels. But how do we determine how difficult any given level should be? This is a good time for us to explain the Adaptivity system, which we used to dynamically change the game's difficulty on the fly. Now, sonification is a concept that most users will not be familiar with, so it's important to ease them in without frustration. But the game should remain challenging if the players start to understand the sonification. So the goal of our Adaptivity design is to choose an appropriate difficulty for each level our users play. It needs to adapt to the skill of the player, so we must also make an estimate of how skilled the player currently is. In order to get data on the player's real ability, levels with the right difficulty must be selected. Levels which are too difficult for the player would result in failure after failure, and likewise, levels which are too easy are not interesting to the player and not interesting to us. We still wouldn't know the player's true skill. And what's worse, our players would be very frustrated. To get the most information about our players, we present them with levels which are just challenging enough. They might fail or succeed. And our estimate for the current skill can be much more accurate. All of our games are played in rounds, and each game has a large level pool to choose from. Each level is of varying difficulty, and our system always chooses the level which best suits the player's skill, though the actual difficulty is mostly unknown and has to be statistically estimated. Currently, Each game's difficulty is based on arbitrary estimations from our developers. Soon, we'll be conducting studies and receiving data from our official Android and PC release. That data will allow us to improve how we calculate each game's difficulty. Now, having seen those 2 games, and having Adaptivity in mind, let's look at the final 3 games we implemented. You'll probably like the next one. Urban UFO is a little bit different. In Urban UFO, you are the pilot of an alien spaceship. You must search the city for a specific human being. Unfortunately, all humans look pretty much the same to you, so you must rely on your advanced Sonification technology to find the exact human you're looking for. Now, this game does of course serve a purpose. It is a more advanced version of the Pinata game, where the player was able to move, but only on one axis. This game gives the player much more freedom to move, which of course makes finding the right target much more difficult. And like in the shell game, the player has multiple choices to find the correct target, even with their eyes. But as the game's difficulty increases, more humans will appear and the player needs to move larger distances. So identifying the correct human by sheer luck will be much more difficult. Alright, 2 more games to explain. The next one's a little bit easier. It's called Dancing Darts, and it's a simple dartboard game. The player needs to hit one particular piece of the dartboard, which they can only hear through sonification. So in a way, this game is very similar to the game Noisy Nuts, except now the training wheels are off. The player must understand how to use sonification, or they won't be able to play this game, which is why we introduce this game a little bit later. This game is also really useful for visualizing our adaptive difficulty system. The number of pieces changes depending on how well the player is doing. Now, time to explain our most advanced game, which is Sounding Submarine. In this game, there's really not much to see, because the player is in a submarine, exploring the depths of the ocean. This game can be played on any axis combination, for example on the X and Z axis, and there is one thing the player is able to do to get some help. They can simply turn on the lights. This drains the submarine's battery, so the player will have to rely on sonification once their battery runs out or once difficulty increases. Now remember, this game can be played in any axis combination, including X, Y, and Z. And this is what we've been building towards. And you might notice, now that we have 3 axes, we're in a similar situation to the operating room, where the surgeon needs to move to a certain position. And with sonification, we can train exactly that task. Aside from the 5 games, our software has some other features, like a profile system that allows different people to play our game, and an achievement system, so users can easily see their progress and challenge themselves. You can try out our software right now by visiting our website. You'll learn about sonification, you'll have some fun, and with your data, you'll help us improve our application. It's available on Windows, Mac, Linux, and Android for free. Before we go, we'd like to talk about what's next for our project. With our Android release, we hope to reach as many users as possible, so a study can be conducted with data from those users. There are 2 possible questions that we could address in the study. We could investigate if the game is enjoyable, or we could evaluate whether our users actually improve their sonification skill by playing the application. And lastly, our group is currently working on a separate project called the Cognitive Training Game. With this game, we're trying to teach users about understanding complex 3D spaces using virtual reality devices. The user's hand is tracked in their real space, and they must navigate a complex 3D maze. We're hoping you'll be able to try out the Cognitive Training Game the next time you hear about our project. Thank you so much for listening to the presentation of CURAT. We're really happy that our hard work finally paid off and that we're able to share our results with you. Please send us a message if you have any questions or would like to talk. And don't forget to try our software by visiting our website. Bye-bye!